So what I propose is that understanding instructional activities without seeing one is super hard. So I'm going to deviate from the norm from a keynote speaker perspective, and I'm going to teach for a little bit. It's not going to be model teaching. It's going to be teaching that helps us think about the decisions required if you're going to be teaching. I'm going to choose content for this teaching that everyone can access, ideally. And in fact, I would be very surprised if you cannot access this content. And I'm going to use one of these instructional activities somewhat explicitly so that we can think about what it means to be a teacher teaching in such a way that they are developing an understanding of what the students understand. So, in order to do that, you will need a partner, but I think I have managed to condition you to that stage, so it should be okay. You should know the people around you, and I propose that we're going to make some assumptions about this, which is that you already know largely how to talk to each other, which is, I think, something that is not true necessarily for students, or even the teachers that I work with. So you guys are a group that sustains itself over time. You've worked very collegially with other people. I'm going to assume that you talk to each other productively. Our objective in this activity is to think like a mathematician. And mathematicians, I don't want to say that they're lazy, but they like shortcuts that they can justify. They would prefer often to have an elegant solution that is brief than a complex solution that is lengthy. So they would ideally like to do less work. And so they try to think about the way numbers work in order to make decisions about what is a reasonable shortcut to use. We're going to start by sort of looking and interpreting what am I asking you to think about, what am I asking you to work out. Then you're going to talk to each other and consider that structure. Then we're going to talk as a group to sort of like see what happens. And then you're going to get a chance to reflect on learning. What's the big idea that we're trying to take away from this activity? Does that make sense? So you are students for a little while, even though I know all of you know this mathematics. There's a tendency to sort of shortcut, let's say, which is to look at the question and try to answer it. Lamb, I know the answer. Our objective is not to answer the question, although that will be a consequence of our work. Our objective is to try to find a shortcut to make finding the answer easy. Okay, that's an important difference. So what I'm going to do is I'm going to show you the problem. And I'm going to ask you to pay attention to it and just to see what you notice about it. Are there any questions about that? Great. Okay, so what do you remember, what do you notice from that problem? Talk to each other. What did you notice about that problem? I'm going to give you another chance to look at it. We'll talk why I did it this way later, but I'm going to give you another chance to look at it. Okay. Now, what did you notice about the problem? Let's try again. I thought I had everybody, but I did not. Okay, we're going to try again. I'm going to show it to you very briefly. Okay, what did you notice about the problem? Okay, let's hear some of these noticings. Again, things we noticed about the problem. Let's hear. Would you like to share something?
Oh, I've got the obvious is it's all addition and subtraction, and some of them are positive and negative.
Okay, so all addition, subtraction, and some of them are positive and negative. Those two ideas are connected to each other. Yes?
All multiples of 9.
All multiples of 9. What else is somebody? Yes?
No parentheses.
No parentheses given. No equal sign given, great.
Well, I got lost in trying to do a strategy, and I was thinking I would have to try to combine numbers to make them, so I only saw that the left half initially, and I was thinking I need to make benchmark numbers so I could get them to add the chart.
The sum of the digits of the separate integers was 9.
Oh, interesting. What else do people notice?
We guess that maybe a 0, representation of 0. If it doesn't, there's no equal, and it's all adds to nothing.
Maybe it adds to nothing. Okay, so this is an inference on based on what you looked at. Okay, what I want you to do is to use one of these things we noticed. I'm going to write them down. Use one of these things we noticed to determine the value of the expression quickly in your head. No pencils. Okay, try to figure out the value of the expression in your head. I'm going to write down the things that people notice.
Well, the sum of the digits in general.
Not just this, but some of the digits.
Right.
Great. Okay, so does everyone have a strategy they can use? I unfortunately had to write that stuff down, which means I did not do what I had planned to do, which is to walk around and hear. So I don't know who I should ask. Literally, I have no idea. But this woman seems really eager. So I'm going to let her go.
Well, they're all multiple designs that factor out the 9, and what do you get? You get 9 minus 8, which is 1, plus 7 minus 6, which is 1, plus another 1, plus another 1, so that's 5, that's 9 is 45.
Okay, so just to clarify, you said, I'm going to change this to, when you say factor, I mean with parentheses. Right, and then you said that this is 9 minus 8. Yes?
Yeah.
And then plus
7.
7. I didn't hear you say all these things, that's why I'm pausing. Plus 5 minus 4. I'm going to run out of space. Plus 4, minus 4 plus 3, minus 2 plus 1. Is that right? And then n parentheses. And then you said that you knew that was 45. How did you know that?
Well, 9 minus 8 is 1, 7 minus 6 is 1, 5
So then-
minus 4 is 1.
You looked at these two and you said these are 1. You grouped these two, yes?
Yeah.
Great. And then you added the ones together, and then you got 9 times 5. That's great. 45. What's another strategy somebody used? Something different. Yes, sir.
I went from right to left.
Right to left.
Negative 18 plus 9 is negative 9. Negative
So you
36
said-
plus 27 is negative 9.
Hang on, let me get this down. 36, 45,
It's just easier. Seems easier.
72, minus plus. Oh, I've got an error. What did I do wrong?
It's
Minus.
negative 27.
Okay, so you said these two are minus 9.
And then the next two are minus 9. And the next two are minus 9. And the next two are minus 9.
Okay.
So it's 81 minus 4 9s or
81 minus 4 9s.
yeah. It's 45.
Which is 45. Another strategy. Yes, ma'am.
So,
I wish I could just press the button and have they go up.
so this is the sandwich method. And, so you start left and right at positive 90, and then keep working in. Negative 72 and negative 18, that's negative 90. Keep working in and you get positive 90. And then, anyway, it all cancels down except for 45, and that's all.
I was concentrating on this.
I knew it, I knew it. I'm just
Okay, try again.
The outer numbers are positive 90, 81 and 9.
So you're saying that this number, well, do you mind? Okay, well, I'm going to have a trouble here. I'm going to talk briefly, meta aside. I want to represent your thinking with what I write up here so that everyone can understand. So to do that, I was planning on drawing connections between the two numbers. Then I realized that you're probably going to connect the next two numbers as well. It's going to make it hard for me.
Oh,
So-
just go up.
What I'm going to do is just make sure I leave myself some
Yes,
space.
that sounds good.
And you're saying that this is
Positive 90.
positive 90.
And
Okay?
then keep working in, negative 72 and negative 18. Negative 9.
I'm gonna,
Better work.
so this is negative 90. Great. Keep going.
Okay, and then the next two working in are positive 90, right? 63 and 27.
Uh-huh.
And then the next two working in are negative 90. These all totally cancel each other, and you're left with 45.
So you're saying negative 90 plus 90, negative 90 is 0. They cancel each other out, and we're left with 45. Let's get one more, because there's a reason for the one more. Sir, I remember you've talked once.
I see 4 differences that result in 90, and result in 9. So 81 minus 72 is a 9, 63 minus 54 is a 9, 45 minus 36 is a 9, 27 minus 18 is a 9, and if you like symmetry, and I do, I put a minus 0 at the end, and then I've got these 5 9s, and that's 45.
9. 9.
And we're not supposed to evaluate that one of these is better, right? But some of us are doing a lot of
You went minus 0?
Yeah, you could. I mean, I didn't have to, but I like that symmetry when I saw the other things going on.
And then you say that's 5 9.
Yeah, 45.
Okay, I'm going to pause there. So, clearly this problem, there's a lot of ways of solving it.
Yes.
What I want you guys to do is I want you guys to reflect on the similarities between these problems and just write a sentence using one of these 4 prompts. So write a sentence using either A, B, C, or D as your sort of structure to think about what's the big idea that connects all of these solutions that we looked at. And I'm going to number the solutions because I think they might be hard to see otherwise. Let's put them in the order that we heard them. 1, 2, 3. So think about or write a sentence that describes, using one of these prompts, that's thinking at the big idea that you've used, rather than the next time you're given this problem, which will be never, that you're going to solve this problem. The big idea. And when you're ready, share that with your partner. Share that big idea with your partner. I'm going to summarize what I heard you say. Protocols.
We like to talk.
That's okay. Okay, so I heard a couple of different big ideas come out, actually, which is interesting. One person I overheard talked about the distributive property as being something that sort of came out a couple of times. Somebody else talked about thinking about the multiples of the numbers, and somebody else talked about, I don't think they use this language, but I would call it the associative property,
Yeah.
where we're sort of deciding what order we want to do this calculation to make the calculation easier. So all three of those, I think, are really productive ways. If we're trying to solve these kind of problems, we really should be thinking about whether we can group the numbers differently. We should be thinking about whether or not we can factor something out of the numbers to make the calculation simpler. And those are sort of big ideas that we can take away the next time we want to calculate something. Okay.